Welcome to Path of Technology, the channel where we make complex tech topics simple and easy to understand. In this video, we discuss the storage device and cloud storage system. Today, we are diving into a subject that affects every single one of us in this digital age, where all our stuff actually goes. In this essay, we explain storage devices and cloud storage systems, breaking down the jargon so you can make smarter choices about your photos, documents, and precious memories. We have all heard the terms thrown around, but what do they really mean for you and your devices? This is the easy-to-read guide that will help learners, new users, and anyone who has ever wondered about the difference between saving a file to their computer and saving it to the cloud. You probably have a phone in your pocket or a laptop on your desk, and both are filled with important information. From your family vacation photos to that critical work presentation, your digital life is constantly growing. The big question is, where should you keep it all? Should you trust a physical gadget you can hold in your hand? Or should you send your files off into the mysterious ether of the internet? This is not just a technical question. It is about security, convenience, and peace of mind. Understanding the fundamental differences between local storage and cloud storage is the first step toward taking control of your digital world and ensuring your data is safe and accessible when you need it most. Let's zoom in on the first category, primary storage. This is often referred to as main memory or internal memory. Its defining characteristic is speed. Primary storage is incredibly fast because it works directly with your computer's central processing unit, which is the brain of the operation. When you launch an application, open a file, or browse a website, the data required for that task is loaded into primary storage, so the CPU can access it almost instantly. This rapid access makes your computer feel responsive and snappy, allowing you to multitask without frustrating delays. The most common example of primary storage is RAM, random access memory. You can think of RAM as your computer's short-term memory. It is volatile memory. Volatile means it requires constant power to maintain information. As soon as the power goes out, what is in RAM is wiped clean. Imagine writing an important essay for an hour without saving, then a sudden outage. All that unsaved work vanishes because it only existed in the volatile environment of RAM. The amount of RAM in your device plays a huge role in performance. More RAM lets your computer handle more tasks simultaneously without slowing down. It is like having a bigger workbench. You can spread out more projects at once without clutter. That is why gamers, video editors, and other professionals using demanding software invest in more RAM. It ensures smooth operation by providing plenty of high-speed, temporary workspace for the CPU to do its job effectively. And remember, always save your work to non-volatile storage before shutting down. Now that we understand primary storage as the computer's short-term, active workspace, let us move on to its essential counterpart, secondary storage, where your files, applications, and operating system are kept permanently. Unlike volatile RAM, secondary storage is non-volatile and holds your data even when powered off. When you save an essay, download a game, or store your photo library, you are placing it into secondary storage for long-term safekeeping, the digital equivalent of a library's archives. Secondary storage is generally slower than primary, but offers much larger capacity at lower cost. A sensible trade-off for data you do not need instantly. To open a file, the system copies data from slower secondary storage into fast primary storage. Then, the CPU processes it. This shuffling is fundamental to modern computing. One traditional example is the hard disk drive, or HDD, long the standard for personal computers. An HDD uses a mechanical arm and spinning magnetic platters to find and record data. With moving parts, it is slower and more susceptible to drop damage. Its major advantage is low cost per gigabyte, great for large video collections or game libraries. A newer star is the solid-state drive, or SSD. Unlike an HDD, an SSD has no moving parts. It stores data on interconnected flash memory chips, similar to a giant USB flash drive. That design makes SSDs significantly faster, more durable, and more energy efficient. Computers with SSDs boot in seconds and launch apps almost instantly. While SSDs cost more per gigabyte than HDDs, their performance has made them the new standard for main drives. What if your data gets lost? Do not worry. cloud storage system is the advanced method to store your important data in cloud servers. Now let us shift our focus from the physical devices you can hold to something a bit more abstract: the cloud. Imagine you have thousands of family photos and important documents. Then one day, the drive fails. It just stops working. Those memories could be lost. This is where cloud storage enters the picture, a modern, powerful solution. In simple terms, cloud storage means storing your data on the internet through a provider that manages storage as a service. Massive, secure networks of servers in data centers worldwide. You are probably already using it: Google Drive, Dropbox, Apple's iCloud, Microsoft's OneDrive. Edit on one device, open on another. Store, access, and sync across devices with internet. The core idea is separating your data from any single device that can be lost, stolen, or broken. Your data lives in a secure, professionally managed environment you can access from anywhere. Powerful backup, flexibility, and convenience. Step 1. You select a file and upload, like putting a letter in a digital mailbox. Step 2. The file is broken into packets, encrypted, and transmitted to the provider's servers. Step 3. It is stored in data centers with advanced cooling, redundant power, and strict physical and digital security. Your file is not on a single server. It is replicated across systems and often across regions. Redundancy for reliability. To open, view, or download, you log in. The service locates and reassembles the file and sends it back. Sharing uses secure links instead of bulky email attachments. Advantages: access anywhere with internet on phone, tablet, or computer. Backup and safety with automatic syncing and redundancy. Easy sharing. Space saving by offloading large files. Disadvantages: dependence on the internet. Offline access is limited. Privacy and security risks. Trusting third-party providers. And ongoing cost for large storage. So, what is our recommendation? For most people, a hybrid approach is the gold standard.